All right. Good morning, good afternoon, good evening, students, whenever you are watching this. This is AP Macroeconomics. This is my channel where I go through full lectures over every freaking thing in the AP Macro curriculum. And today we are covering the first graph of AP Macroeconomics, the production possibilities curve. Yay, graphs! No, okay, so fair warning here. In AP Macroeconomics, there are a total of 6 graphs that you need to be able to draw from memory. They will ask you to draw from memory on the AP exam, or could ask you to draw from memory on the AP exam, that you need to know what they are, what they represent, how they work, what looks like what on it, and then how to change them. Okay, so all of those skills are going to come into play with this. Now, when I'm saying graphs, think, X, Y axis sort of data pots. There's not going to be formulas like in some of your math classes where you type a formula into a calculator. It's going to be more of a, know the general shape and know what that shape means. Why is that a downward sloping line? What does that actually tell us about the real world, etc., stuff like that. So we're covering the very first graph of the class, the production possibilities curve. It's the easiest graph in the class. Love that. But if you have problems with it or questions while I'm going through it, feel free to leave those questions in the comments, and I will answer them best to my ability as soon as I can, as soon as I do see them. So with that all being said, let's get started. So, the production possibilities curve. Fun lecture time, here we go. It's a graph. Let me move my camera so you can read that text. It is a graphical representation of the combination of the amounts of two goods or services that an economy can produce. Effectively, it is a graph that shows different possible levels of production of two goods. You'll have one good on your x-axis, the other good on your y-axis, and the different sort of points on this graph will tell you, hey, this country or economy or business could produce this combination. So if it's really high up on the y-axis, they make a lot of whatever the y-axis is and not a lot of whatever the x-axis is. Conversely, if it's pretty far down along the x-axis, it would be lots of the good that's down here, but not much of the good that's on the left. The basic idea of this graph is to demonstrate scarcity, to demonstrate the idea that things are limited, that we can't make everything all the time, that we have to choose, and those choices will leave us with costs. Most obviously with this graph, opportunity costs. I could have made X number of Y had I not made this amount of good X. Stuff like that. So here's your sort of first starting point with this. So what you have here is a production possibilities table. An example of the graph in number form. You've got bikes and computers as the two quote-unquote goods that this economy can produce, and these are the different combinations of those two goods. So this country can make 14 bikes, no computers, 12 bikes, 2 computers, 9 bikes, 4, 5, 6, 0, 8. These letters are just to correspond with combination names, so you can call it combination A, combination B, combination C, etc. So each point represents a specific combination of goods that can be produced given full employment of resources, meaning these are all good amounts. These are all amounts that exist if this economy is nailing it. If everyone who should be working is working, if all of the machines are operating properly, if they've got good Wi-Fi, everything is working smoothly, if they are producing one of these combinations. The only difference between the combinations is the specific allocation of those resources. They're using them all. It's just at A, they're using them all for bikes. At E, they're using them all for computers. And at B, C, and D, they're using them in different amounts for each good. Okay? Graph these. Draw a quick little X and Y axis graph with bikes as your Y axis and computers as your X. I would recommend skipping in numerals of 2, so your X axis should go 0, 2, 4, 6, 8. Your Y axis go 0, 2, 4, 6, 8, 10, 12, 14 is probably where I would end on that. Draw this graph. Plot these points, where we have them that's at 14 and 0, 12 and 2, 9 and 4, 5 and 6, 0 and 8. Label them points A, B, C, D, and E, and then connect the dots. So draw this graph for me. I'll pause the video while you do that, because I'm going to go on to it here in a second. So pause the video, draw that graph. And it should look like this. The graph should look something like this, where we have our production possibilities curve, also referred to as a production possibilities frontier. That word, don't get thrown off by, it's just a fancier word for the graph. So I mentioned each of these points is a good combination. The line is effectively full employment. So anything below the curve, any combination below your production possibilities curve would be inefficient. There's some level of unemployment. Like if I'm making 2 computers and 6 bikes, something has gone wrong, right? Because based on the table, I can make 2 and 12. So why the heck am I making 2 and 6? Well, that means I'm not using all my resources properly. That could be unemployment of workers, that's the obvious one. But remember, your resources are your factors of production. Labor is just one of those. So unemployment can refer to the underuse of any of your resources. So say you've got factories that are currently not being used. Say you've got specific machines that aren't operating properly. Or that there's some land usage that's not being used in the proper ways or not being used in an efficient manner. All of those things would lead to some level of unemployment. So all those things would get you underneath this curve. The line, and any points on the line, are efficient. You're crushing it if you're on the line. You're at full employment of resources. Now, I need to clarify something right off the bat. This is sort of the first high-level concept to break it down for you. The idea of what full employment is, okay? When the phrase full employment gets referenced, a lot of people tend to think like 100% employment. While that is true for most resources, when it comes to labor, that is not the case. Full employment for us is not having 0% unemployment of labor. It is having what is considered to be only good unemployment. So we have this idea in economics called the natural rate of unemployment, which is like an ideal amount of unemployment. It's not 0 because that's one, unrealistic. The only countries that have 0% unemployment are countries where you are forced to work. So you want to live in like North Korea? Sick, they've got 0% unemployment. Not a win. So we have this idea of this natural rate, which is more of your like ideal level of unemployment in an economy that doesn't force people to work. For America, that number is typically between like 4 or 5% in most years where our economy is operating normally. Because in those situations, having 4 to 5% unemployment is actually fine, because there's a lot of people out there that are in between jobs and are actively searching for one. Those people are unemployed. Is that the end of the world? No, because they're searching. They're looking for a new job. They're transitioning career to career. Sometimes people move from one place to another and to start up in somewhere else, and they're looking for a job. They're unemployed, but is that bad? It's like, I mean, not really. They should have the flexibility to move from one place to another, and in that flexibility, they might have to be unemployed for a little bit. That's okay. That happens. So that's all to tell you that full employment doesn't mean actually 0% unemployment. It's a classic thing that people make the mistake of. Now, this point right here. Outside of the curve, the combination of what looks to be like 7 and 11, which is not meant to be a reference to the convenience store, but happens to work on this graph. That is based on our table and based on what we've seen on this graph visually, not a thing that can be done at full employment. So what the heck is that? That point is impossible or unattainable given our current resources. Given what we currently have, we could not produce combination G in this example. Okay, that is not a thing that we can pull off. It is unattainable, impossible, not an option. Would be cool if we could, but based on what we've got, we can't make that amount. So again, these A, B, C, D, and E's are just telling you what is actually doable and sort of your maximums. If you can do max 14 bikes or max 8 computers or some combination. You can't do 14 and 8. That would be like up over here, which is not possible. 14 is if they just made bikes. 8 is if they just made computers. So what is the point of that graph? Well, to give us a visual of some of our early vocab stuff like scarcity, opportunity cost, efficiency, etc. But also because it'll help us illustrate some assumptions when it comes to economics and give you a basic idea of how graphs work in our class. So, there are 4 big things we assume looking at that graph, which, to be clear, not realistic all the time. First one, the most unrealistic of all of these, is obviously that this model assumes that only 2 goods can really be produced. If you want to make it make more sense to you logically, you can think of this as the 2 goods this economy is most well-equipped to produce. The 2 things they can make the best or the most of. Also assuming that you can have full employment of resources. In some places, full employment isn't a realistic goal. It's just too hard for a lot of countries to hit those levels. Even if it's not 100%, hitting something like 95% employment in some places of the world is just going to be crazy hard. You have a fixed level of resources. The production possibilities curve is oftentimes referred to as a snapshot graph. It is one that when you look at it is stationary because the resources in that visual are fixed. They're not changing. You have this Latin phrase here called ceteris paribus. It shows up a lot in early level economics classes. This just means all else remains equal. Effectively, it means ignore other variables. Like, can land change over time? Yes, absolutely. Land does change over time. How much of land is available to you? A bunch of things will affect that. Your labor changes over time. I mean, you have more people move into your country, people die, a whole bunch of stuff happens there. Okay, capital changes too, because you can have more of it than before or less of it than before. So all of this is to say we assume we've got fixed resources with the graph, and lastly we assume we have fixed technology, because that improves over time naturally. Like, technology gets better and better over time. The more we use it, the more familiar we get with it, the more we can do with it, etc. Now, mentioned efficiency. The graph actually tells us two types of efficiency, vocab term time. First one, you can barely see it because I'm going to make this a little bit smaller. Productive efficiency. It means that products are being produced in a cost-effective way, or the most cost-effective way. That is every point on the curve. Any point that's on that line is a good being produced in the most cost-effective manner. They are using all of their resources appropriately and properly, having the right people make the right amounts of things, have the right machines, etc. Any point on the curve is productively efficient. You also have allocative efficiency, which is saying that the products being produced are the ones most desired by society. Ooh, big sneeze. All right. The products being produced are the ones most desired by society. That is a specific point, and it is the best point on the production possibilities curve. That's where it gets kind of interesting, though, because that point is subjective. If you look at the graph you drew, the bikes and computers one, that's kind of a weird example, right? It's two goods that are pretty different. So what combination is the best? Is it A, B, C, D, or E? Most people tend to say C because it's the most halfway in between, but I don't know if C is the best. D could easily be better. There isn't that much of a difference between those 2 points. And frankly, depending on the situation, A or E could be pretty good. You guys who are in my class live in Texas, a state that is not very friendly towards people who ride bicycles. There aren't a lot of bike lanes on streets. This state is very large, and in the summers, will try and melt you into a puddle. So biking isn't an especially popular hobby. Okay, I teach at a high school. Not very many people bike to school, even though we live in a very suburban area where that should be very possible. Texas isn't very bike-friendly is the reason. So I would wager that points A through C are not allocatively efficient for Texas. Heck, even D probably has us making too many bikes. I would say point E, the one that is all computers, no bikes, is the most efficient point on that graph for Texas, because the bikes aren't particularly useful. But if you go to certain places like California or the West Coast that are much more bike-friendly, or you go to other countries like the Netherlands where more people ride bikes than actually drive cars, those places would be more skewed towards the A, B, C range of that. So the important thing to mention here is that allocative efficiency is 1 point on the curve. It is the best point on the curve because it is the one that people want the most. In order to know allocative efficiency, they have to tell you some information. It's kind of like the opportunity cost thing from the last video, where in order to know the opportunity cost, you need to know the second best option. In order to know allocative efficiency, you need to know what people want. So like this same exact graph, if they tell me I see A, B, C, and D are all productively efficient, if this country has no electricity, just straight up no electricity, that's just a thing for this country. People have no access to electricity. Point A is probably the allocative efficiency, right? I mean, I would definitely assume, because computers are particularly useless if you don't have electricity. Bikes! You don't need electricity for bikes to be useful, so I would say A. It's the allocative efficiency. So again, in order to know allocative efficiency, you've got to know some context for that. Same with opportunity cost. You've got to know some context. Speaking of opportunity cost, the smoothest segue of all time. This is a nice little transition piece, so if you need to take a quick little 2-minute break, pause the computer, go take a quick breath, be like, man, that guy talks very fast. Thank you, I do. I talk incredibly quickly. Let me turn on the fan, actually. It's kind of warm in here. Opportunity cost. So, time for some math. No one's ever excited when I say that. But time for some very simple math, actually, which is calculating opportunity cost as an actual numerical value using your production possibilities curve. Man, that sounds very boring. But the idea is, if I'm at point A, if this country is like, we're making 14 bikes, no computers, and they change their mind, they're like, whoops, computers are useful, shouldn't just make all bikes. And they decide, hey, we're going to go and make B's combination instead. Let's start off slow with the transition. Let's not go crazy here. Let's start off slow. So let's go from A to B. What is the opportunity cost? Well, it's their second option. So what's the second option? In that example, logically speaking, the second option is staying at A, right? They can go from A to B. Those are the two things they're choosing between. They chose B, so they gave up A. But what do they lose by doing that? Well, at A, they had 14 bikes and 0 computers. At B, they have 12 bikes and 2 computers. So what did they lose? What did they give up? They gave up... I'm sorry, I'm going to get the pen enabled for this. I thought that I had them animated on this slide. I have them animated somewhere else. Let me get the pen open for this. Apologies. There's the pen. I don't need an update. It's a pen. So the opportunity cost is 2 bikes. I'm using B for bikes. Be okay with that. Okay, 2 bikes, because they go from 14 bikes down to 12. Some of you might ask, but what about the 2 computers? Well, do they give those up? No, they gained those. So that's not a part of the opportunity cost. That would be a benefit if we were to ask for it. The gain is 2 computers. The cost, because it's opportunity cost, is 2 bikes. That's what they've lost by going from A to B. Okay, following that same logic, solve questions 2 through 5. What's the opportunity cost going from point B to point D, from point D back to point B, because it's going to have a different answer, and point F to point C. Go through those 3 practices real quick and see if you can figure out what the opportunity cost is. What do they give up going from one of these points to the other? Pause the video. And unpause, here we go, let's go through it. So from B to D, at B I'm at 12 and 2, at D I'm at 5 and 6. So from B to D I've given up 7 bikes. And I've gained 4 computers, but again, it's asking for the cost, so I don't have to worry about the gain here, just the cost. Going from D to B, it's the same numbers, but you have to think, what are they giving up? From D to B, I give up 4 computers. Uh-oh, now it's the computers. Wait a minute, what? Why is it computers now? Because it's what you give up. And from D to B, I gain 7 bikes in that move, and I lose 4 computers in that move. Ooh. So be very careful. Direction matters. 4. From F to C, wait a minute. I go from 4 and 6 to 4 and 9. I don't give up anything. Correct. You don't give up anything. That's why F is inefficient. The whole reasoning why F is an inefficient point, why any point underneath the curve is inefficient, is because if I'm at F, there isn't a cost to going up to C. If I'm at F, I have the resources. There are people who could be working. There are machines that could be operating. I'm just not using them properly. That's on me. So there's no opportunity cost there. And then point G, unattainable, impossible, given my current resources. Let's hide that up there for now. Now, Parks and Rec GIF ready to go here. That production possibilities curve was shaped a particular way, a little bowed out curve. It doesn't have to be shaped that way. There is a second way you could see it. So here's a production possibilities table for calzones and pizza. I've got 4, 3, 2, 1, 0, and 0, 1, 2, 3, and 4. If you were to graph this, what you would be able to tell, some of you guys that are pretty good at math or have done a lot of graphing stuff would be able to tell fairly quickly is, looking at this table, this graph is linear, meaning straight line. It is not curved. It is a straight line, a constant slope. The opportunity cost of going from A to B is 1. From B to C, it's 1. From C to D, it's 1. And from E to D, or D to E, it's 1. And going the other way, it's also 1 the whole way down. It exhibits something called constant opportunity cost. If it's highlighted, you should definitely write it down. Constant opportunity cost, which is literal. It means that you've got constant opportunity cost moving from one point to another down your entire curve. And it will happen if the resources for producing either good are easily adaptable, meaning the two goods being produced in the example actually matter. Them being bikes and computers on the previous table seemed like just, random things to pick. And they were kind of random in that I picked two random different goods. Because if you pick randomly different goods, you will get a non-constant slope, because it is not a smooth transition going from making bikes to making computers. They use different resources, different people with different skill sets, so it's not going to be a one-to-one like ratio. It's going to have some hiccups, and it's going to be a bowed out curve. If you have two goods that are incredibly similar, like calzones and pizzas, which here's your pictures for references, and that's what Ben Wyatt from Parks and Rec is talking about, is how much he loves calzones, because he's a person who wants to eat pizza by himself, and it's less sad to do that when you eat a calzone. It's still sad, guys. But calzones are just pizza folded in half that, again, is a little less shameful to eat by yourself. Those two goods have the same resources. Same type of dough, same ingredients, sauce, pepperoni, cheese, pizza dough, etc. It's just made a slightly different way. The people who make pizza could relatively easily make calzones. People who make calzones could pretty easily make pizza. Because these two goods are very easily adaptable, you get a constant slope production possibilities curve. You get a graph that is constant. So you're going to see these graphs in one of two ways. Either a constant slope PPC like this, which happens again if you've got two goods that have very easily adaptable resources, two goods that are made from basically the same thing. Usually food is the most obvious examples here. Tacos and burritos are made from the same stuff, so that's pretty easy. Or you could see a bowed out production possibilities curve, which has increasing opportunity cost. From A to B, it's 2. From B to C, it's 3. From C to D, it's 4. Yes, 4. And from D to E, it's 5. The slope is getting steeper, and the reason why you would have increasing opportunity cost is because your two goods are very different and use very different resources. So it's not going to be a constant, smooth transition going from one good to the other. It's going to be a bit haphazard. There's going to be sometimes where it costs more and some where it costs less. Now, the quote-unquote hardest math thing for today is per unit opportunity cost. Rarely shows up, but boy howdy, if it shows up, kids have no chance of getting it right if they don't see this slide. So make sure you write down this formula and follow along with what I'm doing, and you'll be golden. The per unit opportunity cost is an average. It is telling me for every unit I gain, how much did I give up? The math is very simple. You take the opportunity cost for that move and you divide it by the gain. So those units that we were ignoring before when we just did regular opportunity cost, we will now factor in. So, fairly simple math setup here. If it's opportunity cost over the gain, and I'm going from point A to point B, my opportunity cost, we've already done it, was 2 bikes. The gain is 2 computers. 2 over 2 is 1. And the unit you use here is bikes. You will carry the unit from your opportunity cost. So whatever is up here, the units carry here, because the way you're phrasing it is per unit going from A to B, I'm giving up 1 bike. Because you are giving up bikes, so you want to be framing it like that. It's 1 bike per unit of computers. From B to C, go through the next 3 and solve. Pause the video and unpause the video to see me do it. So from B to C, the cost is 3 bikes. The gain is still 2 computers. So 1.5 bikes per computer. From C to D, we've got 4 over 2. That's a 2. And again, it's bikes. And from D to E, we've got 5 over 2. Which would be 2.5 bikes. So there's your idea of per unit opportunity cost. And again, direction will matter. So if I was doing like D to B, let's say I'm doing that as my practical example of going the other way. From D to B, I lost 4 computers, and I gained, scrolling up here, 7 bikes. You do not have to simplify fractions that are weird. A seventh, I don't think you know that in decimal form. A half, I think you do. So for this one, I would just do literally 4/7 of a computer would be my answer. Because per unit, going from D to B, every time I gain a bike, I am giving up, weirdly, 4/7 of a computer. The math isn't always smooth. That's why I was doing these ones, because the math is much smoother for those. Where it's not going right to left. Get some weird numbers. Oh, disclaimer number 1 time. A thing that will freak you out. On the AP Macroeconomics exam, you are not allowed to use a calculator. There is some math. Most of it is of this type of level, though. Where, like, yeah, they might make you do some fractions and some decimals, but it's going to be like halves and quarters and maybe thirds. But that's about it. They're going to, or tenths, which is 0.1. They're going to give you fractions that are very, very basic. They're not going to ask you what a 7th is in decimal. They're not going to ask you what a 12th is in decimal. Some of you could figure that out fairly easily, but since there's no calculator, they don't want to make that too complicated for you. So halves, quarters, fifths, tenths, that's basically all I see on the AP exam for economics. But be aware there is no calculator on the AP exam. So if you're a person who's not very good at math, you're going to need to practice some of this stuff a little bit. And then all the answers are there. Boom. Okay, you don't have to write all this stuff down. This is just a final example of it, and with the words that I was mentioning of increasing opportunity cost. If you've got an increasing opportunity cost situation where you've got 2 goods that are very different, pizza and robots, shocker, are not made from the same things, that would be terrifying, because either you'd have weird, fleshy, cheese-covered robots, which delicious but terrible, or pizza made from robot parts, which is not edible. So either way, that would suck if these were easily adaptable. They are not easily adaptable. And because they're not easily adaptable, you've got increasing opportunity cost, meaning you're going to have a bowed out, concave production possibilities curve. Looks like someone drawing a bowstring. That kind of thing. Now, a trick question, a question that is meant to trick you, that they could ask off of this, that I've seen a couple of times on FRQs, is the production of which good exhibits increasing opportunity cost. The trick is, even though it doesn't look like it is both, it looks like it is either robots or pizza. If you're actually catching along, the answer is the production of robots that has the increasing opportunity cost, because as I produce robots, I'm giving up a progressively larger and larger amount of pizza. It is increasing both ways because it's per unit opportunity cost that we're technically talking about here. The slope is getting steeper both ways. If it's a curve if it looks like a curve, it's not just curved in one direction, it's curved in both. So technically speaking, the answer, whenever it asks which has the increasing opportunity cost, the answer is always both. It's a trick question. The AP exam loves to do that to you. I'll warn you about those every time I can, because some of them are just stupid. If you want additional practice, you can have it. This is using the pizza and the robot graph. Let me see if I have the answers on this tab. I do! Great. I always worry about that. So if you want extra practice, this is using the previous slide, so it's using, oh boy, using that table's numbers. So if you want extra practice, you can graph that one and then go through these problems. Opportunity cost is going from A to D, from C to A, per unit opportunity cost of A to B, B to D, E to C, A to E. And draw label new point F, where there's 2 robots and 12 pizzas being made, and the opportunity cost of F to C. Okay, if you want to expect us to go for it, I'll show you the answers here really quickly so you can see them. Here are the answers. I'll make that a little bit bigger for you. That does not make that bigger. Doesn't make that bigger either. I don't know if you can see that. That's weird. I can't make that bigger at all. That's super annoying. For number 1, it's 8 pizza. For number 2, I don't know why it doesn't say it, but it's 2 robots. 3 is 1 pizza. That's 1 pizza. B to D is 7 over 2 pizzas, so 3.5. E to C is 2.5 robots, and C is 9 over 2 pizza. A, you draw the point, and there's no opportunity cost going from F to C. There's a little bit of practice if you needed it. All right. Last thing, home stretch. We've almost made it. 30 minutes on the timer? Great. If I can get this done in 45 minutes, it means I've crushed it time-wise, because that's how long my class periods are. So, apologies. My nose is blocked up after that sneeze, so I sound kind of weird. Oh, boy. All right. Did that help? Not really. So the final step, whenever doing any graph for AP Economics, the big step is knowing how to change it, knowing how to shift it, knowing what causes that curve to get bigger or smaller, what causes it to expand in one direction or the other, or shrink in one direction or the other. Okay, your graphs are going to be manipulated. The AP exam is going to throw scenarios at you and ask, what happens to the graph? What does the graph look like after this scenario? So you've got to know how to do it for each graph. So this is the final thing for the graph, which is shifting it, changing it, augmenting, manipulating the production possibilities curve. Make this as simple as I can for you. Those 4 assumptions we had not a few slides, like a dozen slides or so before. Only 2 goods being produced. Not going to change that ever. That would make the graph more than 2-dimensional, and I would hate that. Full employment of resources. Mentioned that sometimes that can't happen when you get inside the curve, so that's fine. The fixed resources and fixed technology thing. The AP exam can very easily throw scenarios at you that changes that. I can make up a scenario where your resources get changed very easily. More people move into your country. Boom, there's more labor. COVID happens, so you have less people who can work and less capital to make places work because you can't have them open. That's a decrease in resources. Technology gets better over time. So those 2 things, while we do assume it when we look at the graph with no other information happening, those 2 things, I can create a lot of scenarios off of those 2 ideas that could potentially change my graph. So there are 4 overall things that can really shift your production possibilities curve. Change in the quantity of resources, mentioned like more labor is an example of a resource quantity thing. Change in resource quality, if I stick with labor, smarter or better workers would be an example. My workers get suddenly smarter. Maybe they all go to like a job training of some type that helps them be more productive. Change in technology, better tech makes you produce more thing, not complicated. And a change in trade. Sometimes you can't do it on your own, but a trade partner or an ally can really help you out and bail you out. For the most part, 4 we will not have to worry about. We'll talk about 4 on a later date when we get, actually in like one of the next couple of videos, we'll get to the trade thing. But these first 3 are the common ones. A helpful abbreviation, because I love doing abbreviations for my shifters because it helps me remember stuff. For the production possibilities curve, the shifters are QQTT. Quantity and quality of resources, technology, and trade. QQTT. QQTT, or QTQT, or whatever you want to do to make that work. Quantity and quality of resources, technology, and trade. Let's show you how this works on the graph. So, robots and pizzas. Moving my camera over here. Okay. What if there is an increase in population? Here's how you do a shift on the production possibilities curve, guys. This is super easy. You're going to love it. I look at my endpoints. So my endpoints are here and here. I'm looking at this. I can make 10 robots. After this scenario, can I make more or less? I mean, increase in population, we would have more people who can make stuff, presumably more labor, right? So we could hire them and more stuff? Yes! If that sounds like terrible, bad logic, congratulations. This is Macro 101. This is economics for dummies. So if there's more people, you can assume those people would actually be able to work and stuff, yes. They're not just all babies. So we can produce more robots. And I look at this endpoint, and can we make more pizzas? Yeah, probably. So I would increase my production possibilities curve. I would shift it out. Huge disclaimer time. I'm yelling it because it's important. On AP exam FRQ day, when you get to the FRQs in your AP exam, they're going to ask you to draw graphs. There are big things you have to do. One, you've got to label your axes, yes, every time. For your production possibilities curves, that'll change based on the scenario. They might tell you it's pizzas and robots. They might tell you it's chickens and geese. I don't care. Whatever the two goods are, make sure that they're on the X and Y axis. Second thing, whenever you shift a graph, whenever you shift a line on a graph, you draw an arrow. You draw an arrow because, and you're going to hate this, this is going to sound really dumb, because the AP exam can't tell which one was first. If you didn't put numbers on your graph, which you're not always required to do, if you didn't put numbers on your graph here and they didn't give you these points to plot out, they just gave you, hey, draw a production possibilities curve for pizza and robots with increasing opportunity cost, which they could do. I would just draw that initial blue line right there. And they gave me the scenario when I shifted it. That line and that line both have increasing opportunity cost. I don't know which one came first. You could have shrunk the graph. So you have to have the arrow to tell the grader, oh, you were here, now we're here. I know that's very dumb, but remember the grader does not know you, does not know your way you're thinking. They could think you're very bad at economics and did it the opposite. It happens. So you got to give them the arrow. The biggest thing on this graph to tell if you shifted it right, or correctly, sorry, is that my endpoints are now further along. You do not need to worry about, hey, is B, C, and D in exactly the right spot? We don't know that. We don't know the severity of the shift. It didn't tell me how many people or what the formula would be of a ratio of people to robot in pizza production, because, like, what the hell would that even be? So these, like, middle points, I don't know what's going to happen to them. They're going to get further out in some way, shape, or form. Shrug. A and E, I can tell what's happening to those. Because A moving up tells me I make more robots now. Because A was just robot production. Me moving E out here tells me we can make a lot more pizzas. Because guess what? E was just pizza production. So those 2 points, A and E, need to move further out to tell me that this is an increase in both. If you drew something like this, I'll give you an example of what would be wrong here. It doesn't tell me anything. It tells me that somehow, some way, shape, or form, really weirdly, at one point or another, they can make more of these things. But then why the heck wouldn't they be able to make more here and here? It doesn't make any sense. So that pink drawing is bad and wrong. When I say increase the production possibilities curve, you need to take the entire line and move it out. Good? Good. I know I'm a stickler for the graph stuff because the AP exam is the most picky about the graph stuff, and it's the easiest way to gain and lose points. Because, like, look at this. As opposed to writing a DBQ, they're asking you to draw this. This is preferable. I love this compared to writing a DBQ, writing like a 3-page essay. Yeah, I can draw 2 lines and an arrow. That's much better. So make sure you're doing it right because they're very big sticklers on it. Okay, more examples. Oh, God. I hope you couldn't hear that. Oh, geez. Sorry, I don't know how to mute the audio on this weird slide. I don't know where it comes from. It just terrifies me every time. I'm going to turn down the audio a little bit on my headset. Oh boy, that hurt. So, technology improvements in pizza ovens. Just pizza ovens get technology improvements. Okay, I go to my thing. I look at these endpoints. Robots. Does this help me produce robots? No. Like, cool that there's better pizza ovens, but it doesn't help me make robots. Does it hurt me making robots? No, it doesn't affect it, right? This scenario doesn't affect robot production. It doesn't mean anything for the maximum amount of robots I can produce. That doesn't do anything. I go down to this point and look at pizzas. What is this? I can make more pizzas, right? If I got better pizza ovens, I can make more pizzas. So, my shift should look something like this. Now, it could be more dramatic. That's fine. If you wanted to draw it like that or that, that's also okay. I'm giving you a less dramatic one. But it needs to be an outward shift specifically of the X values. This needs to move over to the right. Has to. Need to have an arrow for that. And that point has to stay there. This point right here has to remain steady because this does not affect robot production at all. So my just producing robots point shouldn't change. But my places where I make pizzas could make more pizzas. So I could reasonably move out all of the rest of these points over to the right. I sure as hell need to move out that end point where I'm just making pizzas, because this will help that. So whenever you're doing production possibilities curve, what you've got to think is, does this scenario help my y value and / or my x value? Does this scenario hurt my y value and / or my x value? If it helps one of the two values, then you move that point out and draw the arrow. If it helps both, you move the whole line out. And if it hurts them, you'll move them in. So a example where it would hurt them. Natural disaster. Stop making the noise. A natural disaster. That's bad. Because if a natural disaster hits any place in your country or in your economy, it's going to hamper your ability to produce things. You can't make as much because your roads get hurt, your ports, if it's like a hurricane, get messed up. Travel is harder, which matters for things like production because you got to ship stuff places. So this will hurt production. No one should have to debate me on that. Robots. Can we make as many robots? If the natural disaster hit us, probably not, because I would say that it's going to at least... natural disasters tend to kill people, and people are a resource that we use to make things. So if there's less of them, then sorry, we can't make as much. So robots should scale down. Pizzas. Same thing. We cannot make as much. This is not how much people want. This is what is possible production. So can we make as many pizzas? No. We might need pizzas more, but we can't make them as much. So I would shift the thing in. My points, and this is bad on this one because it got cut off when I scrunched it. My points, the end should move in. Arrow pointed inward. An inward shift at the production possibilities curve, because I'm moving it inside of itself, is a shrink. Moving it outward is an expansion. And then conversely, a robot-caused disaster, where it's entirely robots that do the bad thing. The robots are the only bad people here, and they only destroy robot stuff, or we just don't trust robots as much. You could see it just shifting down robot production. Or if there was like mad cow disease, which would affect cheese, that's only a pizza problem, so that would just cut down the pizza production. Something like that. In terms of weird, big picture stuff you want to be aware of for this, like in terms of things that are like very important for students to know in terms of like long-term in the course, here's the one way this gets thrown into like long-term stuff. So let's say I've got Panama and Mexico, these two countries. I've got their production possibilities curves for two goods, and I actually made the goods much more broad. The x-axis is consumer goods. Remember, that's goods that are immediately consumed up, like food. And the y-axis is capital goods, things like technology, things we use to help us produce stuff. This point right here is their current choice that they're making, the level of production and the what good they're prioritizing. It's at full employment, which is great, and they're prioritizing consumer goods. They should see growth off of that eventually, because if you think, we got more food, we can feed our people, okay, we should see more people over time, which will shift our curve out. To be clear, this is a theoretical thing, not a drawing thing. It's just giving you a visual for a theoretical thing. That's their future, right? If Mexico has the exact same production possibilities curve, but instead favors capital goods, what would happen to their long-term growth? What is better for long-term growth, making consumer goods or making capital goods? The answer is capital goods. The reasoning for this is actually kind of logical. When you invest in capital, it helps you produce everything else, including consumer goods. Think of how much food is mass-produced now, or at least how much food relies on technology. Farmers need machines to help them produce stuff. You could have a bunch of farmers working out the fields picking out food, but if you have a machine that can do it much faster, you'll be able to harvest more food. So even if you prioritize capital goods, that could still end up gaining you a lot more of both in the long term because of how technology is useful in much more of a broad spectrum and, importantly, is reusable. Consumer goods are used and go away. Capital goods last and have utility. What this is telling you is that for long-term growth, capital goods are better to prioritize than consumer goods. Okay, almost done. Here is your last little bit. Draw a production possibilities curve with increasing opportunity costs for pizza and robots, like the ones I've been doing and draw what happens on them for these 3 scenarios. Okay, draw what happens on those graphs in these 3 scenarios. New robot technology, decreased demand for pizza, mad cow disease kills a whole bunch of cows. And then draw, I'll skip this last bit. I'll show these, but I'm not going to go through these in full detail because I don't want this video to be too much longer. So I've got these scenarios here as well, which I will show you the answers to, and I'll briefly explain one of them because one of them does require an explanation. So pause the video, go through these 7 examples real quick. Okay, going through them one by one. Robots, pizzas, robot making technology. That helps me make robots, doesn't help me make pizzas at all. Should see this change. Shift outward, but only for robots because this does not help me make pizzas at all. 2, trick question. This one is super important to focus on. Decreased demand for pizzas. I'm looking at it. Does this affect my ability to make robots? No. Does this affect my ability to make pizzas? No. This does not change my maximum level of production for pizza. It will change how much pizza I make. It does not change how much I can make. Here's what I would think. I would think more along this. My allocative efficiency is shifting. That point that is ideal is moving. Because people don't want pizza as much. Okay. Does that affect my ability to make pizza? No. I'll choose to make less pizza and make more robots, but my maximum level of production wasn't affected. Big brain stuff right there. Mad cow disease kills 85% of cows. I cannot make as much pizza. I'm sorry, goat cheese. There's not enough of you to go around. This does not affect robots at all because they don't care about this. Pizza production will shift inwards. It won't be able to make as much pizza. Okay, capital goods, consumer goods. Oil spill in the Gulf. What does that do? What is oil? Well, oil is a resource, and oil is used in the production of a bunch of things because of shipping costs. This would actually shift down both things. Oil is technically a consumer good, but it's a consumer good that is used in the production of a bunch of stuff. It's a resource. Remember, it's quantity and quality of resources, and oil is a resource. Less oil means can't ship things, meaning I can't produce as much stuff if my shipping costs are higher. Oh boy. So decrease in both. That's why oil spills are real bad for, not just for the environment, because obviously they're bad for that, but they're also bad for your economy, because like oil, important. Faster computer hardware. Can I make more capital goods? For sure. Can I make more consumer goods? Also for sure. It's a resource that is used to help make those too. Consumer goods are also made using technology. Shift it out. Okay, think of all the factories that process butter. Okay, they would have computers there, right? Okay, well, a faster computer means they can do their stuff faster. That includes processing things. All right, increase both. Unemployed workers. Okay, careful here. Unemployment. That's already on my graph. I already have that. Do I need to move the line to show unemployment? No. I would do this. I would move to a point inside the curve. If I decrease the entire curve, that means my maximum level of production is lower. The workers going unemployed doesn't change my maximum level of production. It just changes my current level of production. That is tricky as hell. That is very difficult for a lot of people. Don't worry. If you got like, what? Yeah, that's very tricky for a lot of people. Because the line is full employment. Full employment is still the same. This doesn't change what our level of production would be if everyone was working. This changes what our level of production is right now, which would be like the point that you're currently operating at would now be inside the curve because you've got unemployment. And lastly, increases in education. Why does this matter, Mr. Teacher Man? Easy. Human capital. Human capital, your workers' knowledge and skills, that's a resource, baby. Better resource. Curve shifts outward. Labor is smarter, works harder, works better, is better at doing things, because when you're smarter, you tend to actually produce more. This is accurate. Because you can innovate is usually the reasoning. It's not because you're better. It's because you can innovate because you have more ideas, because you have been exposed to more ideas. So education is good for that. All right. That took a little bit longer than I was hoping, but that is the entirety of the production possibilities curve. That is a whole lot of information to throw into one video, guys. That's an entire graph, one video, bing, bang, boom, done. And me explaining how graphs work and all of that stuff. So reviewing that video, the things you've got to make sure you understand. What is the production possibilities curve? Great. How do I draw it? Do I draw it with a curve or do I draw it with a straight line? That'll depend on what resources you're given. If it's two goods that are very similar, straight line. If it's two goods that are very different, curve it. How do I find opportunity cost or production possibilities curve? Math, you subtract stuff. Per unit opportunity cost. That's the cost over the gain. Remember, the unit is the same for your opportunity cost, so you just carry that unit over. And then, how do I shift a production possibilities curve? Big to know what shifts your production possibilities curve. What do I do when they throw a scenario at me? Cool, how do I draw that change? Great. In class, we're going to practice this on the following day of whenever we watch this video. Following school day, we'll do practice over this as an actual graded thing, as a formative grade, but you'll be able to work together and use this video to help you and ask me questions and all that stuff. So be ready for that. Thank you very much for watching this video. I wish you the absolute best of luck going forward. See you guys.